Hello everyone, in today's video I will be teaching you how to derive the formula for volume of a sphere by using the calculus concepts of integration and solids of revolution. Now, most of you have just been told for your entire life that the volume of a sphere is 4/3 pi r cubed. You know, it works, it's always right, it's easy, and that's fine. But in this video I'll just go into more depth and show you why that formula actually works and how to actually derive this formula. So integration and solids of revolution are both basic calculus concepts, and if you understand basic calculus, you should have no problem understanding the remainder of this video. Solids of revolution is an important concept, and you have to be able to visualize it in your mind. Solids of revolution is the idea of taking a function and revolving it about one of the axes. In this video, I'll be using the x-axis. So in order to create a sphere, you would have to take a semicircle and revolve it about the x-axis, and that's where this solids of revolution comes into play. Now, many of you may find this hard to picture in your mind, so I have some pictures here. Here we just have a basic semicircle. Now you can see that the semicircle has started its revolution about we'll call this the x-axis. And I'm hoping you're starting to see now how this is going to become a sphere. The semicircle is continuing its revolution, and now the semicircle is almost completed its revolution, and now you see it's all done and it's formed a sphere. Here you have the semicircle that we started out with. We revolved it about the x-axis and it gave us our sphere. I'm going to use this exact idea when deriving the volume formula. First, I'm going to draw a circle. I'm going to assume that the center is at the origin. This is r. This is negative r. So, using the standard form, equation of a circle, this can be expressed as x squared plus y squared equals r squared. Solving for y squared equals r squared minus x squared, and taking the square root of both sides, y equals plus or minus the square root of r squared minus x squared. Now, this plus or minus actually won't be needed because, as I showed in the previous pictures, we only need a semicircle in order to revolve it and create a sphere. So, we only need the positive part of the circle. Therefore, we're just going to use the equation y equals r squared minus x squared. I'm going to copy that equation over here, y equals square root of r squared minus x squared, and I'm going to copy that semicircle picture. Now, there is a formula to find the volume of a solid that's created by using solids of revolution, and that formula is volume equals pi multiplied by the integral from a to b, those being the lower bound and upper bound, of f of x squared dx. Now f of x is just the function that you're revolving about the x-axis. So I'm going to rewrite y equals r squared, radical r squared minus x squared, as f of x equals square root of r squared minus x squared. This is the function that we're going to use. Now, I'm just going to solve this by putting in all my values into the formula. A and b, our lower bound is negative r, right there, and our upper bound is r, right there. Squaring f of x, so since it's square root of r squared minus x squared, when you square that, you will simply get r squared minus x squared dx, meaning with respect to x. Now, since the sphere is going to be a completely symmetrical figure, we can just take the integral from 0 to r as long as we multiply the volume by 2. So we're basically taking half of the sphere and multiplying it by 2, and I put the 2 out in front. And then we just simply write this again. I'm going to put this on the next page. 2 pi 0 to r squared minus x squared dx. Now, we simply solve this. Since r is a constant, it will become r squared x when you take the antiderivative, and x squared will become x cubed over 3, going from 0 to r. Substituting r, we have r cubed minus r cubed over 3. There's no need to substitute 0 because that will just end up being 0. As you can see, r squared times 0 will be 0, and 0 cubed over 3 will be 0, and it'll just fall out. So there's no need to do that. R cubed minus r cubed over 3 becomes 2/3 r cubed, and multiplying those together, you end up getting 4/3 pi r cubed. And that is the formula that you've been using. And we have just derived the formula by using integration and solids of revolution. Thank you very much for watching this video. I hope it's helped you. Please leave any comments below.